So this is higher, Paper 1, 2012, question 21. We're asked to show that x minus 4 is a factor of this degree 3 polynomial. So let's set up a division. So we're dividing this polynomial, 1 lot of x cubed minus 5 lots of x squared, 2 lots of x plus 8 by x minus 4. The process is to bring that 1 down, multiply by 4, add, multiply by 4, add, multiply by 4, and add. So the question now is, what on earth have we found out? Let's compare this with, say, dividing some numerical example where we divide, say, 5 into 13, and we know it goes 3 times, 3 fours are 12, with a remainder of 1. So what can we say about 13? We can say that 13 is 4 times 3 plus 1. So in the same way, we can say that x cubed minus 5x squared plus 2x plus 8 is equal to, now that was 4 times 3, so this stands for x minus 4. It's the value of x that makes this 0. So it's x minus 4 times, and then corresponding to this 3 would be this. Now this was an 1, 2, 3, 4, a cubed term, squared term, just the term x, and a constant, x cubed, x squareds, x terms, constants. So there's one less here, so instead of x cubed it will go down to x squareds, x's, constants. So it's 1x squared minus 1 lots of x, the constants minus 2. And the plus 1 remainder that we had here, there's a 0. So we have a plus 0 as a remainder. So let's go back over this. We have this number 13, which we're dividing by 4. So the equivalent over here is this row of number here, and this row of numbers here, which stands for this degree 3 polynomial. If you want the correct term for this, it's the dividend. You don't really need to know that word. It's nice to know there are words like that. So dividend is the thing you're dividing. And then we have the divisor. So in this case it's an x minus 4. That's what this 4 stands for here. That's the thing you're dividing by. So the x minus 4. And then we have the quotient. How many times does x minus 4 go into this polynomial? How many times did 4 go into 13? It went 3 times. So this is the quotient. So there is the quotient. And then finally we have the remainder. In this case it was plus 1. In this case it's 0. So 13 divided by 4 goes 3 times, remainder 1. X cubed minus 5x squared plus 2x plus 8 divided by x minus 4 goes x squared minus x minus 2 times with a remainder of 0. Now for this question we're asked to show that this is a factor. Then our conclusion is that x minus 4 is a factor of that degree 3 polynomial, x cubed minus 5x squared plus 2x plus 8, since the remainder is 0. It goes exactly. If we had something like 4 divided by 12 divided by 4, it would go 3 times, remainder 0. What we're saying about 12, we're saying that 12 is 4 times 3 plus 0. 4 goes exactly into 12. 4 is one of the factors of 12. Here we're saying that x minus 4 is one of the factors of this polynomial. So let's now move on to part B of the question. Let's remove most of this. We'll keep the main result, which is this here. Get rid of all this rough working. So I'll preserve this, put it up here. And let's now have a look at the next part of the question, which asks us to factorize x cubed minus 5x squared plus 2x plus 8 fully. Now what we've done so far is we have one factor and another factor. It's, I suppose, in a way it's like taking the number 30 and saying, oh, it's 2 times 15. Is that it factorized fully? Well, no, it's not, because 15 we know is 3 times 5. So this part, this second part here, can be factored further. So let's just write this down. We so far have x cubed minus 5x squared plus 2x plus 8 written as a product of two factors, x minus 4 and a quadratic factor, x squared minus x minus 2. And we're exploring basically whether this quadratic factor factorizes further. So let's do our usual routine, reversing the FOIL thing, which are the firsts give you x squared, so x and x. We forget about pluses and minuses just now. Let's look at the 2. That would be a 1 times 2 is the only possibility. So the outside 2, without considering pluses and minuses, will get a 2x, and the inside 2 will get a 1x. And these outsides and insides combine to give us minus 1x, this middle term. So how do we combine these to get minus 1x? Well, there'd be a plus 1x minus 2x would give us minus 1x. So the 2x term, that's this one, has to be negative, and the 1x term, that's this one here, has to be positive. You always, after doing this, should double check by multiplying out using your FOIL process. The first's x times x, x squared, outside 2 is minus 2x, inside 2 1x, which gives us minus 2 plus 1x is minus 1x, and the last's plus 1 times negative 2 does give us minus 2. So there we have the fully factorized version of this polynomial, this degree 3 polynomial. There's 3 linear factors, x minus 4, x plus 1 and x minus 2. So let's move on now to the third part of the question. We'll get rid of that rough working, and I think we should maybe preserve this part of it so that we know what we have achieved so far. And let's now look at the last part of the question, which says we had to solve this equation equals 0. So we've got a cubic equation to solve, and the left hand side's the polynomial that we've been exploring. It's the polynomial that we've managed to factorize. So solving the equation x cubed minus 5x squared plus 2x plus 8 equals 0. Our task is to factorize the left hand side. We've done it. X minus 4 times x plus 1 times x minus 2. There are 3 factors. So this times this times this gives me 0. Somewhere in this product there's a 0. There has to be a 0 lurking away. Whether it's the x minus 4 that's the 0, or the x plus 1 that's the 0, somewhere in there there's a 0. If this was the 0, x would be 4. If this was the 0, x would be minus 1. And if this was the 0, x would be 2. So we have solved this cubic equation. We have 3 roots for this equation. So now moving on to part B of the question. We'll keep a record of these 3 solutions. So I'll put these up there, and let's examine the diagram that we're given. So here's a graph of the values that this polynomial takes for various values of x along here. The heights of the points on the graph give you the values of this polynomial. That's why it says y equals. Y coordinates of points on this curve give the values of this polynomial. Now, we've certainly found out the value of the polynomial when x equals 4. It's 0. When we put a 0 in there, when we put a 4 in there, this becomes 0, and you multiply these together, you get 0. We solved the equation, when is this polynomial equal to 0, and out popped these 3 values. So in order from the smallest to the largest, minus 1, followed by 2, followed by 4. So there's x equals minus 1. The curve crosses the x-axis there. The y-coordinate of the point on the curve is 0, as it is this y-coordinate on the curve here when x equals 2, as is the y-coordinate on the curve when x equals 4. So the solution to this equation, the 3 roots, are given by the point where this graph crosses the x-axis. Now we're asked to find this shaded area, and that's integration now. We have to find the integral from 0 to 2 of whatever the formula for this curve is. Well, that's our x cubed minus 5x squared plus 2x plus 8. So that's what we're now working out to get the exact area of this shaded part. So here it is, and let's proceed. So x cubed integrated, increase the power and then divide. So this becomes x to the 4 over 4 minus the 5 sits there, increase and divide. So it's x cubed over 3 plus the 2 sits there, increase, there's a 1 there, that goes up to 2, divide by 2, plus if you integrate 8 you will get an 8x. Why? Because when you differentiate back 8x you get an 8. You can always check by differentiating back. So that's the expression that we need to plug a 0 and a 2 into. Is it simplified? No. This part can be simplified slightly. So let's do that. We've got x to the 4 divided by 4 minus 5 lots of x cubed over 3 plus these 2's cancel. We get an x squared plus an 8x. And it's between 0 and 2. So we're going to subtract two expressions. The first one is the value of this when x equals 2. If you like, we can put that up there to remind ourselves. And the second one is the value of this when x equals 0. So let's now plug in 2 into this. We've got 2 to the power 4 over 4 minus 5 times 2 to the power 3 over 3 plus 2 squared plus 8 times 2. For the second one, 0, 0, 0, 0. That's going to be the values. There's no point in writing out all the various bits like 0 to the power 4 over 4. We know this is going to come to 0, so is this, so is this, so is this. So the second bracket is 0. So we have to find the value, evaluate this first expression. Now on the bottom of this fraction we have a 2 times 2, on the top we've got a 2 times 2 times 2 times 2. So a 4 will cancel there. Maybe I should put this down to see what we're doing. Bottom line, there's a 2 times 2. So we can divide top and bottom in effect by 4. We're left with 2 2's, which is 4. The next one won't cancel down. 2 cubed is 8. 5 8s are 40. We have 40 over 3. We have a plus 4. We have a plus 16. We can tackle the whole numbers. 4 and 4 is 8 and 16 is 24. And we're taking away 40 thirds. Now, several ways we can now do this. We could either change this into thirds to get 72 thirds, multiplying this by 3 to get 72. So that's 72 thirds minus 40 thirds. And how many thirds do we now have? 72 of them minus 40 of them. So that's 32 thirds. Or we could have said, okay, it's 24 minus 3 into 40 goes 13 and 1/3. And if we're taking 13 and 1/3 away from 24, 13 away from 24 would be 11, and take away another third, that's 10 and 2/3, which is the same as 32 thirds. Now this is an area, it's a shaded area, so we basically have to say what the units are, and it's square units. So that's the area that's shaded.